The law of inertia states that any object or body will remain in its current state of rest or velocity until disrupted by an external force. In this video, my board and I possess kinetic energy due to being in motion. The mathematical formula E equals half mass velocity squared is used to determine an object or body's energy, this being measured in joules. In utilising this energy, I am able to change my velocity and direct myself into rotation. Though due to lack of both airtime and speed, there is only enough time for one rotation before gravitational force pulls me back to the ground, again affecting my current state of velocity. For example, if this rotation were performed in space, where the gravity is significantly less and there is neither wind resistance nor friction, I would continually rotate with a constant velocity. Once gravity has forced me to the ground, my board starts to slow down almost instantaneously due to the friction of the snow, causing negative acceleration. In this particular case, the external force of friction affected my board immensely, as the texture of the snow was extremely sticky due to previous rainfall. Had this have been ice, my board would have continued to slide in motion for a much longer period of time, and if there had been no friction, air resistance, or forces from external elements, I would remain at that same velocity in my current state indefinitely. This video establishes not only the effects of friction and gravity, but also the use of kinetic energy on an object's state of rest or velocity, subsequently demonstrating the concept of inertia. If my mass is 57.2 kgs and I have an acceleration of 3 meters per second squared as I progress down the hill, my force as a given mass would be 171.6 newtons. Conversely, if my male friend Jake has a mass of 88.9 kgs and an acceleration of 3.3 meters per second squared, then his net force would be substantially greater than mine, as according to Newton's second law, force equals mass times acceleration. Therefore, his net force would be 293.37 newtons. Newton's second law of motion states that the acceleration caused by the net force of any object is directly proportional to the mass of said object, meaning that for an object to accelerate, it will require a force inversely relative to its mass. If Jake and I were riding on flat terrain and required an external force of wind to assist in reaching a drop zone, due to Jake's mass being greater than mine, the wind would need to exert greater force on him to gain the same momentum as myself, this being the measured product of both our mass and velocity. This law may be seen as an extension of the first, as if Jake and I remained at rest on our boards, in order for our current state to change, an external force of wind would need to act upon us. In Jake's case, a stronger force would be necessary. This photo exhibits the difference between the two, if the same force were to act upon us, conclusively demonstrating Newton's second law. Along with wind, forces such as friction and gravity are considered unbalanced forces, as they are able to change a cause in motion, while balanced forces keep an object at rest, exerting an equal and opposite force on that given object, thus leading me to discuss Newton's third law. This law states that for every force, whether that be balanced or unbalanced, there will be both an equal and an opposite reaction. When referring to the balanced forces that are associated with Newton's third law, the exerted force from the rider when carving, and the snow itself exerting a force of both an opposite and equal magnitude back on the rider, allowing them to remain upright and progress in the desired direction, are a good example. This photo demonstrates the unbalanced forces that may affect a rider when referring to Newton's third law of motion, displaying the net force of 293.37 newtons from Jake being transferred to me during collision. Although my mass is considerably less, according to this law, I will apply the relative force of 293.37 newtons back to him in response. In relation to Newton's second law, however, this collision is likely to affect me more so than Jake, as the mass of myself is significantly less, and in revisiting his first law, this photo also establishes how the considerable magnitude of force being inflicted disrupts my current state of rest.